So we are discussing a new topic, that is differential errors and approximations. When we say dy by dx, we already know that dy by dx, meaning of dy by dx is limit delta x tends to 0. In differentiation we discussed that limit delta x tends to 0, delta y upon delta x, change in x, then corresponding change in y. So delta y by delta x, and when limit delta x tends to 0, delta x is coming closer to 0, that is nothing but the dy by dx. We say dy, it's not like that dy is divided by dx, that's not the meaning, but we are now discussing a different situation now, where you will be getting of meaning dy by dx like dy when divided by dx. Okay, just see that limit delta x tends to 0, delta y upon delta x is nothing but dy by dx, and that dy by dx is nothing but f dash x, that also can be written as f dash x. At the same time, delta y by delta x can also be written as f dash x plus some small value, small epsilon value. Epsilon kuch keh diya maine, because it is when limit delta x tends to 0, right? When delta x is coming closer to 0. If it is not like that, then delta y by delta x is equals to f dash x plus some small values there. So that delta y is equals to f dash x into delta x plus this epsilon into this delta x can be written as. Now that's a small value, but again multiplied with a small, very small value. So that multiplication is going to be much smaller value. So that's a very small value there. So through approximations, I can say that delta y is equals to f dash x delta x. Through approximations, I can say that okay, that is a negligible value. So delta, through approximation, delta y is equals to f dash x delta x. So that can be written as delta y is equals to f dash x is nothing but dy by dx into delta x, and that is delta y. So this delta y is equals to dy by dx into delta x, right? That will be using in the problems there. Now at the same time, there are three terms there in errors. Three terms: absolute error, relative error, and percentage error, right? When we say absolute error, change in x, which is delta x, in x, change in x, that is delta x. So delta x in x is nothing but the absolute error there. If I say relative error, change in x is delta x. If I say relative error, that relative error is going to be delta x upon x, check, and then percentage error. And that percentage error is nothing but delta x upon x into 100. So these three terms you will be getting in the questions. You will have to take care about that. Absolute change, whenever we say, that's an error. In terms of error, when we say delta x in x, relative error is delta x upon x, and percentage error is delta x upon x into 100. And likewise, if we discuss about this absolute change, the absolute change in x is going to be delta x, relative change in x is going to be delta x upon x, and if I say percentage change, it is going to be delta x upon x into 100. That will be using in the problems which we are going to discuss now. Now just look for one more concept there before starting the problems. What we have written, that delta y by delta x is equals to f dash x plus some small value epsilon there. The delta y can be written as, just now we have written like that. Okay, that's a very small value. Just now we have discussed. That's a very small value. So that delta y is equals to f dash x delta x. And through approximations, we can definitely say that delta y is equals to dy, is equivalent to dy, which is equals to f dash x delta x. That is the differential in y. Differential in y, we can write that the differential in y is equals to f dash x delta x, right? That dy is equals to f dash x is dy by dx into delta x. right? At the same time, that is differential in y. If I say differential in x, if it is differential in x, it can be written as dx is equals to dy by dx. In fact, if I say differential in x, that is going to be dx. In place of y, it is x, dx by dx into delta x. So it will become 1. So dx is equals to 1 into delta x. So what we are getting there, that delta x is coming equivalent to dx. And finally we can write there dy is equals to dy by dx, and the delta x is nothing but dx, and that we will be using in the problems, that dy is equals to dy by dx into dx, right? So that's the approach there. And do remember about the changes there. If I say absolute change in x, that is delta x in x, relative change in x, that is delta x upon x, and if I say percentage change in x, that is delta x upon x into 100. Now the question is, the radius of sphere decreases or reduces from 10 to 9.9 centimeter. Initial radius is 10, then decreases to 9.9. Find the approximate decrease in the volume of that sphere. Radius decrease हो रही है, volume भी decrease होगा. Radius is decreasing from 10 to 9.9, and corresponding decrease, approximate decrease in volume is required. Okay. So radius is 10. It is decreasing. R plus delta R is coming as 9.9. So that delta R is equals to minus. It is reducing actually. So it is minus of that delta R is 10.1. Volume of that sphere is given as 4/3 pi r cube, right? So that dV by dr with respect to r, if I differentiate that volume, it is 4/3 pi into r cube is 3r square is the derivative of that function. It is 4 pi r square. We calculate dV by dr. We calculate dV by dr at r equals to 10. It will become 400 pi. This dV by dr at r equals to 10 is coming as 400 pi. Okay. Now to calculate the approximate change, to calculate dV, we will be using the relation dV is equals to dV by dr into dr, right? The dV by dr at r equals to 10 is 400 pi into that dr. Dr is nothing but the change. The delta r is equivalent to dr minus of 0.1. So it is negative minus of the dV, it is decreasing minus of 40 pi. The delta V, approximate change in the volume, approximate decrease in the volume, since it is negative, so it is decreasing. Decrease in the volume is delta V is given as minus of . These are the steps. Now the question is, you have to find out the approximate change in the surface area S of a cube. And what type of cube? Cube is side x meters, and that change is that surface area S of cube with side x meters caused by increasing the side by 2%. When its side is increased by 2%, what is the approximate change in the surface area? Actually, initially the surface area is S and side is x. That is given to you. If we are changing the side from x plus delta x is the change there. Then S plus delta S is the new surface area. So we have to calculate the approximate change in the surface area. That means we have to calculate delta S with respect to change in delta x. What has been given to you is caused by increasing the side by 2%. It is given in terms of percentage. So initially it is So initially the side is x, then it is been increased by delta x. So it increasing the side by 2%. That 2% is what? That delta x by x into 100 is equals to 2. It is given in terms of percentage. So delta x by x into 100 is given as 2. And we want delta s, approximate change in the surface area. S is equals to surface area of a cube. When we say volume of cube, it is x cube. When surface area of cube, it is 6x square. We differentiate that with respect to x. ds by dx, it is 12x. Right? It's ds by dx is equals to 12x. We calculate ds, okay, that ds by dx is coming as 12x. Now to calculate ds, change in the surface area, that ds can be given as ds by dx. We are calculating it at for the side x meter only, so there is no need to put value. ds is equals to ds by dx, that ds by dx is equals to 12x. The ds by dx is equals to 12x. What is that delta x? What is that dx? It is the delta x is coming as 2 by 100 into x, and that delta x is nothing but equivalent to dx. So that we will be calculating that, we will be putting that dx 2x by 100, that is ds is equals to 24 by 100 into x square, and that dx is 0.24 x square, and that dx, that ds, which is equivalent to delta s, is equals to 0.24. That's how we are going to calculate the approximate change in the surface area. Approximate change in the surface area, delta s is required. When given is what? When the side is increased by 2%, that is delta x by x into 100 is equals to 2. So that is the procedure there. Now the question is, you have to find out the percentage error in calculating the volume of cube if an error of 2% is made in measuring the length of edge of cube. There is an error of 2% in length of edge of cube, and corresponding, definitely there is going to be corresponding error in calculating the volume of cube. Right there. Volume of cube, so volume of cube is written as V equals to x cube. Now there is error of 2%. Initially x is the edge of cube and corresponding to that volume is V. Now there is an error of 2%. So delta x by x into 100 is equals to 2. 2%. Initially it is x, but there is an error of 2%. So delta x is the error in x. Delta x is the error in x. So delta x by x into 100 is equals to 2. Okay. And what we want percentage error in calculating the volume. So percentage error in volume, जो calculate करना है हमें, that is del V upon V into 100. That's what we want to calculate. So okay, V is equals to x cube. Differentiation with respect to x, dV by dx is equals to 3x square. Right, that is dV by dx. From here we can write del x is equals to, delta x is equals to 2x by 100. To calculate dV, we use the result as dV is equals to dV by dx into dx. That dV by dx is 3x square into dx. What is that dx? This delta x equivalent to this dx is 2x by 100. So it is coming as 6x cube by 100, which is dV. and which is definitely equivalent to delta V. What we want to calculate? We want to calculate, that is the change in approximate error in volume, but we want in terms of percentage. So in terms of percentage, delta V upon V into 100, so that is nothing but 6x cube upon 100 into volume is x cube into 100, so that error is nothing but of 6. That's nothing but the percentage error. So 6% error is there in volume if there is an error of 2% in length. So that's there in terms of percentage. Now the question is, if radius of a sphere is measured as 7 meters with an error of 0.02 meters, find the approximate error in calculating the volume. There is an error in calculating radius, so there is going to be error in calculating the volume. So what is that approximate error in calculating the volume? So according to the given information, radius is 7 meters. There is an error of 0.02 meter. Del R is 0.02 meters. An approximate error in calculating the volume, that means the requirement is of del V. What is that approximate error in calculating the volume that's required there? So volume of a sphere, that is 4/3 pi r cube. With respect to r, we have differentiated that 4/3 pi 3r square, it is 4 pi r square, that is dV by dr. Okay, and that dV by dr at r equals to 7. That will be 4 pi into 7 square, 4 into 49 pi. That is dV by dr at r equals to 7. We require approximate error in calculating the volume. So dV by dr is known to us. To calculate dV, we use the relation dV upon dV as dV upon dr into dr. The dV is equals to, the dV by dr at r equals to 7 is 4 into 49 pi into that dr. What is that dr? Is given as 0.02. So that dV is equals to it is clearly in terms of meter cube. So that is dV, that's what we have calculated, and we want approximate error in calculating volume, that is delta V, that is equals to, because dV is clearly equivalent to this delta V. That's we are going to calculate the approximate error in volume. Error in radius, error in volume is required. Volume with respect to r differentiated, that r equals to 7 is the value there for which you have to calculate. Kept the value of r equals to 7 there. And that's the procedure. Now the question is, a circular plate, metal plate expands under heating, so its radius increases by 1%. Increase in radius is given in terms of percentage is 1%. You have to find out the increase in area of plate. So definitely when radius increases, area also increases. So we have to find out the approximate increase in area of plate. It's not in terms of percentage, it's approximate increase in area of plate if radius of plate before heating is 15 centimeter. First of all, area of circular plate is pi r square. Right? Radius is increasing by 1%. So radius is increasing in terms of percentage. Initial radius is r, increase is delta r. In terms of percentage, it is delta r upon r into 100 is equals to 1. Clear? Initial radius is r, increase in that radius is delta r, And in terms of percentage, so delta R upon R into 100 is equals to 1. Fine. An approximate increase in area of plate is required. Approximate area, that is nothing but delta A is what? That's our requirement. It's not in terms of percentage. If percentage is also asked, we can find out that percentage. But filhal, it is delta A is required there. So area of is pi r square. Again I write here. With respect to r, we have differentiated that. Right? And then dA by dr at what? Initial radius has been given to you as 15 centimeter. That is equals to 30 pi. So dA by dr at r equals to 15 is been given to you as 30 pi. We want to calculate approximate change in area. So to calculate dA is equals to dA by dr into dr. From here, delta r is equals to r by 100. So that delta r is equals to r by 100, and that is clearly equivalent to dr. Right? So that dA is equals to dA by dr. What is the dA by dr at r equals to 15 is 30 pi. And that dr is nothing but r by 100 fine. And actually that r has been given to you, initial radius has been given to you, that r has been given to us as 15 centimeter. So we kept that value. That dA is equals to 450 pi by 100, or that dA is equals to 4.5 pi, or we can say that delta A, because the dA is clearly equivalent to delta A, so that delta A approximate increase in area is going to be 4.5 pi centimeter square. That is approximate increase in area of plate. Right? That is the approach. Circular plate expands when radius is under heating, so that its radius increased by 1%. That is the meaning, radius increased by 1%. In terms of percentage, so del r upon r into 100 is equals to 1. So delta r is equals to r by 100. Initial radius is 15, fine. The delta r is equivalent to dr. That is area of circular plate. Differentiation of that with respect to r differentiate kiya, then kept r equals to 15 there. We got 30 pi as the dA by dr. And to calculate dA, we have used this relation. dA by dr has been kept here. This is dr, that is r by 100 for r equals to 15 that we have kept there. That is dA. Right? And if percentage increase in area is required, then delta A upon A into 100, right? That delta is 4.5 pi upon A is pi r square into that area, clearly that area is r is known to us 15. Right? And if we calculate that, we are going to get the percentage increase in area. That is the approach. Now the question is, while measuring the side of an equilateral triangle, an error of A percentage is made. you have to find out the percentage error in its area. There is an error of, while measuring the side of an equilateral triangle, error of A percentage is there. Side, let's say side of that equilateral triangle is X. So error is A percentage, that means delta X upon X into 100 is equals to A. X is the side of equilateral triangle. As far as area of equilateral triangle is concerned, it is root 3 by 4 x square. Now percentage error in its area is required. For that we have calculated dA by dx with respect to x. Differentiate this, root 3 by 4. That means our requirement is what? If A is the area there, we want percentage error in its area, that is nothing but delta A upon A into 100. That's what we have to calculate. That's very clear to us. So dA by dx is equals to root 3 by 4 into x square, derivative is 2x. So that is dA by dx. Fine. That will be root 3 by 2 into x. Now, as per the procedure to calculate dA, we will be using here dA is equals to dA by dx into dx, right? So that dA is equals to, that dA by dx is what? Root 3 by 2 into x into dx. What is that dx? That delta x upon x into 100 is equals to A. So that delta x is equals to A into x by 100. And that delta x is clearly equivalent to dx, right? So we have calculated that, we have kept the value of that delta x as dx here, ax by 100, right? So it becomes dA, that is equals to root 3 by 2 A into x square by 100. Fine. Actually it is the absolute value change in the area, but we want percentage error. So to calculate percentage error, the dA is clearly equivalent to delta A. So delta A divided by, we want delta A divided by into 100. That is the percentage error in the area. So delta is this value, root 3 by 2 x square by 100. That's what we have calculated there, upon area, root 3 by 4 into x square into 100. So now we can calculate, and that is becoming is twice of A. That percentage error in, there is an error of A percentage is made in the side, and so area is what? Area, percentage error in area is twice of A. It is becoming twice of A. Now the question is, the pressure and volume of a gas connected by the relation PV raised to power 1 by 1, PV raised to power 1.4 equals to K, and you have to find out percentage error in P, percentage error in pressure corresponding to a decrease of half percentage, 1 by 2 percentage in volume. Percentage decrease of volume is been given, and percentage error in pressure is required. Percentage error in volume, that means the given information here is delta V upon V into 100 is equals to half, right? Percentage decrease in volume, and actually it is negative, it's with minus sign, because it's a decrease. Percentage error in P is required. Percentage error in P is required, that means delta P upon P into 100. That's what we have to find out. So definitely first we'll be calculating the pressure and volume, that relation is given. So we'll be calculating dP by dV. We'll be calculating dp by dv there. Just calculate that. So we are going to calculate dp by dv with the given relation pv into 1 pv raised to power 1.4 equals to k. So taking log both sides, we'll be taking to differentiate. First we take log, we can apply the product rule also, but we are taking first log there. We want to differentiate with respect to volume. We want dp by dv, so we want to differentiate with respect to v. But before of differentiation we are taking log there. If I take log, multiplication comes in addition, power comes in multiplication. And that's how we can take log both sides. Now differentiation with respect to v. You can differentiate it using the product rule also. 1 by p dp by dv plus 1.4 derivative of log v, that would be 1 by v. With respect to v we are differentiating, and then it is 0 there. So 1 by p dp by dv is equals to minus of 1.4 upon v. So dp by dv is equals to minus of 1.4 p by v, that is dp by dv. Now we can write again. To calculate dp we can use the relation dp equals to dp by dv into dv. So that dp is equals to, we want percentage error in p, that dp is equals to dp by dv, that is minus of 1.4 p upon v, and from here we can write del v is equals to minus of v upon 200, del v is equivalent to dv, right, minus of v upon 200. So it is becoming, dp is coming as, v is getting cancelled there, 1.4 p by 200. We want percentage error in p, so equivalent to delta p, percentage error delta p upon p into 100, that will be equals to 1.4 p upon 200 into p into 100. So it is going to be, p is getting cancelled there, 1.4 divided by 2, right? That is the percentage error in p. That percentage error in p is coming as 1.4 divided by 2. Now the question is, show that relative error in volume of sphere, show that relative error in calculating volume of sphere due to error in measuring the radius, is approximately equals to 3 times the relative error in radius. 3 times relative error in radius, and we want relative error in volume of sphere. What is the relative error? When we say relative, there is 3 terms actually: absolute error, then relative error, and then percentage error. When we say absolute error, change in x when we calculate delta x in x. We just calculate delta x. What is the change in x, that is delta x in x, is the absolute error. When we say relative, so delta x is the change in x. So delta x upon x is relative error. And when we say percentage error, that is delta x upon x into 100. Absolute error, relative error, and percentage error. We have discussed questions based on the percentage error. Now there is a question based on the relative error. So we have to calculate this. In percentage error, delta x upon x into 100. We have to calculate that error in percentage. So it is into 100. In relative error, it is simply delta x upon x. So now coming back to the question. Relative error in volume of sphere. Relative error in volume of sphere. Delta V upon V is due to error in measuring radius is approximately equals to 3 times relative error in radius. That's what we have to prove. That's what we have to prove. ये हमें prove करना है. ठीक है. So volume of sphere, that is V equals to 4/3 pi r cube dV by dr. 4/3 pi, derivative of r cube is 3r square, is going to be 4 pi r square. That is dV by dr. Now to calculate dV, dV can be written as dV by dr into dr. So that dV is equals to 4 pi r square dr. Now relative error in volume. So we want delta V upon V in terms of relative error in radius. Okay. So what we have done there, I have written here dV by V. I have divided it by V. Volume से हमने divide किया. And here to calculate delta R upon R, multiplication and division by R. Okay. Delta dV upon V is equals to 4 pi R cube upon V dr upon R. dV upon V is equals to, we are calculating as per our needs, 4 pi R cube upon volume is 4/3 pi R cube dr by R. It is going to be dV by V is equals to 3 times dr by R. ठीक है, dV by V equals to 3 times dr by R. That's what we want to calculate. Due to approximation, we can definitely write delta V upon V is equals to 3 times delta R upon R. Yes, it's coming, right? Now we take a NCERT based question where you have to find out the approximate value f of 2.01 where fx is equals to 4x square plus 5x plus 2. Approximate value of 2.01 where fx is given. Okay, 4x quadratic expression, 2.01 is required, right? So we have taken here x is equals to 2, x plus delta x is 2.01. So clearly delta x is coming as 0.01, right? That delta x. F of 2, what is the value of, we want 2.01. So what is happening at 2? It is actually 2.01, which is 2 plus 0.01. So at x equals to 2, value of that expression, quadratic expression is coming as it is 16 plus 10, 26 plus 2, 28. Fx is 4x square plus 5x plus 2. That's the expression if I differentiate it with respect to x, f dash x. That is nothing but 8x plus 5, and which is nothing but dy by dx. Right? We are also aware of the fact that to calculate dy, we can write dy is equals to dy by dx into dx. To calculate dy, we can write dy is dy by dx into dx. So that dy is equals to dy by dx. That dy by dx at what point? We want at x equals to 2. So that dy by dx at x equals to 2 is coming as 16 plus 5, 21. So it is 21 into, what is that dx? That delta x is coming as 0.01. That is nothing but equivalent to dx into 0.01. Right? That is delta x, which is equivalent to dx, which is 0.01. So that dy is 1, and that dy is nothing but equivalent to delta y also. So to calculate fx at 2.01, so f of 2.01 if it is required, जो हमें find out करना है, that is going to be, f of 2.01 is going to be y plus delta y. So y plus delta y what is that y? Y at f x equals to 2. That is nothing but the y at x equals to 2. Corresponding to x equals to 2, what is the value of f of 2? That's y. That is 28. Plus that delta y is 0.1. It is coming as 28.2. That's how you can calculate the approximate value. We can calculate f of 2 and then with the help of that f of 2.01. Now again NCERT based question, you have to find out the approximate value of 5.001 where fx is x cube minus 7x square plus 15. 5.001 function is known to us. So definitely we are going to write that x is equals to 5.001. X plus delta x is equals to 5.001. So that delta x is equals to 0.001. Okay, that is delta x. Now at x equals to 5, we also calculate value of function f of 5. What that f of 5? It is 5 cube minus 7 into 5 square plus 15 is 125 plus 15, 140. It is 25 into 7. 125 plus 15 minus 25 into 7. What that value is coming as? $175. Tick. That is f of 5 minus of 35. Now fx is x cube minus 7x square plus 15. We differentiate this given function f dash x 3x square minus 14x is f dash x, which is nothing but equals to dy by dx, right? And then we calculate dy by dx at x equals to 5. So that will become 25 into 3, 75 minus 70, which is coming as equals to 5. So that dy by dx at x equals to 5 is coming as equals to 5. That is f dash x. Now, to calculate dy, we'll be using the relation dy is equals to dy by dx into dx. That dy is equals to, where dy by dx at x equals to 5 is 5 to that dx. What is that dx? That dx is, delta x is 0.001, which is equivalent to dx 0.001. That is dy, and that is clearly equivalent to delta y. We want to calculate f of 5.001. So f of 5.001 is nothing but y plus delta y. Y is the value of that function at x equals to 5. What is the value of that function is f of 5, which is minus 35. And that dy, which is equivalent to delta y, is 0.005. And if you calculate that, you are going to get the exact value of, approximate value of f of 5.001. That is the approach. Now the next question is about using differential, we have to find out the square value of 29 raised to power 1 by 3. Earlier we have calculated the square root of 401, approximate value of a square root function. Now it is approximate value of a cube root function. Now you have to find out 29 raised to power 1 by 3. It is a cube root function. We will be taking the function as, जो function हम अपनी तरफ से consider करेंगे, that is going to be x raised to power 1 by 3. Earlier we have taken root over x. It is 29 there. So 29 and raised to power 1 by 3 will be taking the closer value. जिसका cube root हमें पता है, that is clearly 27, and 27 का cube root, that is going to be 3. So we'll be taking x as 27. So corresponding to x equals to 27, 27 के corresponding when we take y, that will be equals to 27, and cube root of that is going to be equals to 3. We'll be taking, we have taken the function as, at the same time, we have to calculate 29. So x plus delta x is equals to 29. So delta x is going to be equals to, x we have taken as 27. So delta x is going to be equals to 2. That delta x is clearly equivalent to dx, that we are always going to take. Y is equals to x raised to power 1 by 3. We are going to differentiate that. It is dy by dx is equals to 1 by 3 x raised to power 1 by 3 minus 1. It is equals to 1 by 3 x raised to power minus of 2 by 3. Right? That is dy by dx. So we are going to calculate dy by dx at. dy by dx calculate करेंगे at x equals to 27. 1 by 3 into 1 upon 27 raised to power 2 by 3. 3 cube, cube cancel होगा. 1 by 9. 3 it is going to be 3 cube, cube cancel हुआ, 3 power cancel, 1 by 9, it is 1 by 27. So we are getting dy by dx at x equals to 27 is 1 by 27. To calculate dy, we'll be using the relation dy is equals to dy by dx into dx. dy by dx at what? At x equals to 27 is going to be 1 by 27. That dx is nothing but 2. It is 2 by 27 there. This is dy, and that dy is clearly equivalent to delta y. We want cube root of 29. That is going to be y plus delta y. So y is what? Y is 3 and delta y is 2 by 27. So just divide 2 by 27 and add in the 3, you will be getting the cube root of 29. Now the question is, using differential you have to find out the approximate value of 80 raised to power 1 by 4. Earlier we have discussed square root, then cube root, and now it is fourth root of 80. So 80 raised to power 1 by 4, it's a fourth root of x. The fourth root of 80, we are going to take the function as y equals to x raised to power 1 by 4, and definitely the nearest value around 80, जिसका fourth root आपको idea, that is clearly 81. So we are going to take as x is equals to 81 there. Corresponding to x equals to 81, it is y is equals to, it is 3 raised to power 4, so it is 3 there. We want to calculate 80. We have taken x is equals to 81, so x plus delta x is equals to 80. Fine. X is 81 plus delta x is equals to 80. So delta x is the negative value there, which is minus 1. That is approximately, that is through approximation we can definitely write delta x is equivalent to dx. ठीक है. Y equals to x raised to power 1 by 4. Differentiation with respect to x, will be calculating dy by dx at x equals to 81. It is 1 by 4, x raised to power 1 by 4 minus 1. So it is 1 by 4, x raised to power minus 3 by 4, or that dy by dx 1 by 4, 1 upon x raised to power 3 by 4. We want to calculate dy by dx at x equals to 81. To power 3 by 4, it is 1 by 4 into 27, that is dy by dx at x equals to 81. It is 1 divided by 108. So that is dy by dx at x equals to 81. Now it's okay, delta x. To calculate dy, we will be using the relation dy is equals to dy by dx into dx. So dy by dx at x equals to 81 is 1 by 108 into dx, that dx is minus 1 there. So that dy is equals to minus of 1 upon 108, which is equivalent to delta y. So 80 raised to power 104, value of that can be written as y plus delta y. Y is 3 there and delta y is minus 1 upon 108. And when you calculate 1 upon 108, and if you subtract from 3, you will be getting the 80 raised to power 1 by 4. So that's the approach to calculate approximate value of square root function, then cube root function, fourth root function. Now the question is, using differential you have to find out the approximate value of root over 0.48. So again, as we have discussed, approximate value of a square root function, it's a square root function root over 0.48. So definitely we'll be looking for a value which is closer to this 0.48. So we have taken x is equals to 0.49 and take the function as usual as y equals to root over x. So we have taken x is equals to 0.49 and y is equals to root over x. That's the function there, a square root function. So for x equals to 0.49, value of y is equals to 0.7. Now x plus delta x we want value of this 0.48 in square root of that. So x plus delta x is equals to 0.48. So delta x is going to be equals to 0.48 minus 0.49, that will be minus of minus of 0.01, right? Now we take that is clearly equivalent to dx. Now y is equals to root over x. We differentiate that function, dy by dx, that is 1 by 2 root x. So dy by dx is 1 by 2 root x. We want dy by dx as at x equals to 0.49. .49 square root of that, that will be 0.7. It is going to be 1 upon 0.14. That is dy by dx at x equals to 0.49. Now, to calculate dy, we use the result dy is equals to dy by dx into dx, right? So that dy is equals to dy by dx at x equals to 0.49, that is 1 upon 0.14, and that dx is nothing but minus of 0.01, right? That is nothing but minus of 1 by 14, that is dy, and which is again equivalent to delta y. So to calculate root over 0.48, so root over 0.48 is equals to y plus delta y that is y is 0.7 plus minus of 1 by 14. When you calculate that, you are going to get the approximate value of root over 0.48. That is 7 by 10 minus 1 by 14, and you can calculate that in terms of decimal. So that is the approach. Observe the question carefully. It is 0.48. Just think about 0.49 because it is having the square root as 0.7, nearest value to this, having the square root, exact square root as 0.49, which is known to us as 0.7. X plus delta x is 0.48. So delta x is minus of 0.01, which is equivalent to dx. Differentiate the function y equals to root over x. We have to find out the square root, approximate value of a square root function. So we have taken assumption of a square root function. Differentiate that, take x equals to 0.49, and then calculate dy using the result dy is equals to dy by dx into dx. Kept the values here, and we are getting minus of 1 by 14, which is equivalent to delta y. So it is y plus delta y. Root over 0.48 is required. Y is 0.7, delta y is minus of 1 by 14. Calculate that, and you are going to get the exact result. So now we are calculating the approximate value of a square root function, cube root function, fourth root of that function, trigonometric function, logarithmic function, and we will be looking for the approach or procedure to find out that. We are taking the first function or the first value for which you have to calculate using differential. You have to find out the approximate value of root over 401. So what is going to be the approach to find out root over 401? That's clearly a approximate value of a square root function. So square root function कि आपको approximate value find out करना है. So first of all, just consider the square root function. We have taken the function as y equals to root over x. You have to find out root over 401. तो आप 401 के near value search करेंगे, जिसका square root आप easily आप find out कर पाते हैं, that is nothing but 400. Because for 400, square root would be coming as 20, which is near to, very near to 401, nearest value. So we have taken x is equals to 400, right? So corresponding to x equals to 400, value of y is no doubt 20. We want to calculate root over 401. So actually it is x plus delta x is equals to 401, right? X is 400. Okay. So delta x, that delta x is coming as 401 minus 400, that is 1. So that delta x is coming as 1. Now since we have taken y equals to root x as the function, approximate value square root function की find out करना है, y equals to root x and differentiate that function with respect to x. It is dy by dx is equals to 1 upon 2 root x. Fine. So it is dy by dx. At which point? So definitely we are calculating at x equals to 400. So dy by dx at x equals to 400 is equals to 1 upon 2 into, for x equals to 400 square root 20, it is 1 by 40, right? That is dy by dx. Now to calculate dy. To calculate dy, we are going to use the result always dy is equals to dy by dx into dx. So to calculate dy by dx is already known to us as 1 by 40 into dx. What is that dx? That delta x is coming as 1 and which is clearly equivalent to dx. So that dx is 1. So you are getting the value of dy there, and that is the dy. We want to find out root over 401. So root over 401 is nothing but y plus delta y. Y, that y is what? Y is for 400 it is 20 plus delta y. We have calculated dy, that is clearly equivalent to delta y. So it is 20 plus 1 by 40. It is coming as 20 plus 0.025, that will be 20.025. That is the approximate value of a square root function root over 401. So since you have seen the function square root function 401, so you have taken square root function, you have considered the square root function y equals to root over x. X is 400. Why we have taken? Because 400 is the nearest value to this 401, for which square root is known to you directly is 20. Fine. So x is equals to 400. We have to find out root over 401. So x is equals to 400. X plus delta x is equals to 400. We want to find out the value of root over 401. So 401 की value find out करना है आपको, square root of 401. So x plus delta x is equals to 401. We have taken x is 400. So delta x is coming as 401 minus 400, which is 1. Taken the square root function, differentiate that function with respect to x and keep x equals to 400 there. You will be getting the dy by dx there. Now to calculate dy, we want root over 401. Na? So we have calculated root over 400 is already known to us as 20. So to calculate dy, dy is equals to dy by dx into dx. That dy by dx has already been calculated. That dx is nothing but the approximate value when we are calculating that delta x is equals to 1 is clearly equivalent to dx. So we have kept the value of dx as 1 there. So you got the dy, right? And that dy is nothing but actually delta y, change in y. So root over 401, that's what we want to calculate, is y plus delta y. For root over 400 it is 20 plus delta y, and added these two. That's the approach. When we are going to calculate cube root function, we will be taking the function as y equals to x raised to power 1 by 3. If you want to calculate logarithmic function, you are going to take the function from your side as y equals to log x. So that's the approach there. Now the question is, using differential, you have to find out the approximate value of log of 10.02 with base e, and in the question itself it has been provided to you that log 10 is given with base e is 2.3026. So approximate value is required, log 10 is given, and log 10.02 is required there. Same concept is there. Definitely you are going to take the function as log x, y equals to log x. been given to you. So x is 10 there, x plus delta x, we want to calculate it for 10.02. X is 10, so delta x is going to be equals to 10.02 minus 10, that is 0.02, that is delta x there, which is clearly equivalent to dx. Y equals to log x is the function. So differentiation with respect to x, it is going to be dy by dx is equals to 1 by x there. So dy by dx you want to calculate at which point? Dy by dx at x equals to 10, which is going to be 1 by 10, that is dy by dx. Fine. And then to calculate dy, we will be taking dy is equals to dy by dx into dx. So that dy by dx at x equals to 10 is going to be 1 by 10 into that dx is nothing but 0.02. So we got the value of dy. Yes, it is again equivalent to delta y. Fine. So to calculate log 10.02, that will be equals to y plus del y. So clearly for x equals to 10, value of y is given to you is 2.3026 plus that delta y 0.02 divided by 10. So when you calculate this, you are going to get the exact result. It is 2.3026 plus it will be 0.002. So it will be 2.3046. That's the approximate value. Same procedure remains whether it's a logarithmic function.